Oh, perfect. Thank you. Cool. So, hello, welcome. Happy week one. I am Alexander, your instructor slash facilitator for the next 10 weeks. A little bit about me, and then we'll kind of dive into the expectations for this live session. Yeah, my name's Alexander. I have been teaching this specific cohort for about 6 months now, Karen. And before this, I taught data science for 5.5 years through some of our local university. I'm located in Dallas, Texas, so I taught through Southern Methodist University, SMU, and then went online when COVID started and did boot camps and certifications and micro courses like this over the following 5 years. So I'm pretty comfortable with the material. Excited to kind of guide you all in your journey here, and at least on the educational side. In terms of practice, I am a practitioner. My background is in data science. My master's was in data science. I used to work in professional sports. I worked for the front office of a Major League Baseball team, the Texas Rangers, doing analytics and their Moneyball type ideas of bringing data science and decision making based on analytics kind of to the forefront of that industry. And currently, I work at Databricks, which is a cloud data intelligence platform whose mission is to try and help customers and help organizations find intelligence and bring AI and data engineering kind of to big data at scale. So I'm sure you'll hear a lot more about all of that over the course of the next 10 weeks. I do like this type of session. I only wish we had more live sessions, but I know there was a couple comments in one of the discussion posts about like the fact that this is instructor led, and I really appreciate that. I've led a few courses that were completely async, where it's just participating in forums, and I don't feel like you get across that same sense of engagement with the material or even clarification of the material as you do with live sessions. If you want to connect with me on LinkedIn, I'll drop this in chat. It's kind of a couple of pictures. We won the World Series in 2023, so I was able to be a part of that team, which was very cool. In my role at the Texas Rangers, I ended up leading their data engineering team for about 2 years. So 2022 and 2023, I kind of refactored our entire cloud platform in terms of our data engineering and data landscape. So yeah, in this course, even though it's focused on data science, we're going to be talking about data engineering. We'll also be talking about AI and how we make actions based off of AI agents and all that things at the very end. But we'll also kind of stick with the classics of data science. So making exploratory data analyses, making reports, making visualizations, making your data actionable, training machine learning models, supervised and unsupervised models, trying to find classical representations of, I guess, AI on top of your data. And then I have a lot of supplemental material I'll add in on top of data engineering and agentic AI, which are kind of my bread and butter right now. Cool. So again, plan for today. I want to make sure we're all comfortable in the platform. We all kind of know what we've signed up for over the next 10 weeks, kind of the expectations of the week to week. And then I have some material on data science frameworks. Again, I kind of like week one because it's almost like syllabus week, but it still kind of moves fast because it is like a 10-week boot camp. So we got a lot of material to cover here. Spoiler, week two is kind of crazy. So make sure you have some extra time maybe for next week here. I'm not sure if you can all see this. If you scroll to the very bottom of the cohort of the platform, that's left toolbar, you'll see all the different labs and things available for you. These are going to be your hands-on labs. And if you notice, week two has like a lot of labs. Again, we'll go over expectations of what you should and shouldn't do with these labs and things, as I've gone through all of them and executed all of them and everything. So yeah, week three, you see it's only like what, one, two, three, four, five compared to like the dozen in week two. Anyway, cool. So let's start kind of with the platform and kind of what we have all signed up for here. So we're going to be working within our IBM online campus. You'll notice that a lot of the material is going to be curated by folks at IBM, as well as some of the additional material that I will provide. There'll also be optional ways to interact with IBM's cloud. So yeah, fun fact, if you didn't know, IBM does have a cloud. It's on cloud platform. So the big clouds are, of course, Azure on Microsoft, AWS through Amazon, and Google Cloud Platform, GCP through Google. But there's other clouds out there, including IBM's cloud, as well as Alibaba, I think, also has a cloud. And Oracle now has its own cloud too, which is kind of funky. I don't know how many people actually use Oracle Cloud, but it's there if you want it, if you want to use it. But yeah, in terms of the material, it should translate pretty seamlessly across both industries as well as concepts. We're going to dive deep into Python and then also use that to construct our EDAs as well as train our machine learning models. All right, so hopefully we've all had a chance to log in and kind of work our way through the platform. You had a week or so to start navigating your way through the orientation modules, and I think the orientation modules do a really good job of kind of giving you an understanding of the expectations for the course. I'm actually going to go into one of the discussion forums, or maybe it's in the announcements. I can't remember where I put everything. I also hate how it goes into like new tabs sometimes. Yeah, the forum space is kind of funky, as you've probably experienced. So you just have to be gentle with it, and it should work. So yeah, as we said, kind of working through each week, you're going to have individual modules that we'll do some examples of here in a minute. Those modules will be at your own pace, where you can basically do some readings, watch some videos, do some like learning. Then you'll have discussion forums that try and synthesize some of the material and also gives you a way to participate with the other students in the cohort. And finally, there'll be hands-on modules where you'll have guided walkthrough kind of coding assignments that you'll do on your own time. And that's also what I'll review during lecture here as well. Typically, most weeks, not week one, but all the other weeks, they'll end with a hands-on coding kind of, I guess, capstone. Not really capstone. What's the word here? I guess keynote, maybe. So at the end of like week two, for example, there'll be a hands-on project for you to do. Maybe not the assessment, but somewhere around like I think like 211. So during our live session, if there's any of those like hands-on activities without answers, I will prioritize working through those. Otherwise, I'll just pick a couple of the most important notebooks from the week and we'll run through them live together. So that way you can see my own interpretation of the logic as well as the questions and the answers of kind of what's expected of you on those notebooks. So that's kind of the breakdown of each week. You're going to have discussion forums, you're going to have modules, and then you're going to have hands-on labs in terms of coding exercises. Let's see. Week starts on Wednesdays and run through Tuesdays. So they added the live session in kind of close to the end of the week. So again, my job is to review the content of the week, not necessarily kind of introduce it to you for the first time. So like I just mentioned, it's up to you to kind of take the initiative and work through some of these hands-on labs before the live session. Again, let's take week two, for example. Technically, the live session is called 2.13. That means everything before 2.13 is up for grabs in terms of you, in terms of reviewing it, as well as on me on covering it. And again, week two specifically has a lot of different concepts around Python as we do a crash course on learning how to code. I won't be doing every single lab in week two, but I will pick a couple of the important ones or the complicated ones or the ones that I've seen students in the past trip up with, and that's what I will cover. So again, think of the live sessions as a great swath of material, but I'm not going to get granular in everything that you should have reviewed. I only have an hour and a half here. Technically, the last 30 minutes are like office hours, but I typically use the whole time to lecture and maybe give the last 10 minutes. And again, if you have to hop off after an hour, you're more than welcome to. Everything will be recorded and sent and reviewable on your own. I also back everything I do hands-on up to my GitHub, which again we'll review here in just a moment. Let's see. The last thing is to break down in terms of what you've signed up for. This is kind of the overview of the course. We're going to start with data science methodologies. So running through kind of thinking like a data scientist. What does it mean to be a data scientist? What are some of the projects and what are some of the things we think about? Then we actually get into the meat of the cohort. We have 2 weeks on Python. Mostly week two is like introduction to coding, and week three is more about like a soft introduction to data collection and data engineering. So how do we start writing code, writing programs that are mostly good, or at least how do we review AI code with and make sure that we know what it's doing? Again, don't just copy paste code from Claude or ChatGPT. We should know what it should be doing. I don't know how many of you saw some of the things from the Super Bowl yesterday, but there were like a million AI commercials, and a lot of them like weren't even like really relevant. So there was one that was like AI.com that doesn't even sell anything yet. It's like, what are we doing? Anyway, don't just trust AI code or AI kind of content. Always at least review things to make sure that it's trustworthy and you know what it's doing. Week 4, this is our SQL week. It's just you should know Python and SQL in data science. So we have one, I think we get in the SQL ad hoc throughout the rest of the program, but this is just dedicated to what is SQL. Then we get into the real meat of the problems. Now that we know how to write code in Python and SQL, how to get data and clean it up a little bit, now we finally get into the meat. How do we create exploratory data analyses? How do we create basic models? What is a linear model, right? Why do we need all this stuff? How do we make effective visualizations off of that data? And then finally, how do we do classical machine learning? How do we train our tree-based algorithms to make predictions for regression and classification? And how do we do both supervised, unsupervised, and also use that with LLMs, large language models, to do some of this? If you have ever think that like classical machine learning is obsolete now because we have AI agents, that is definitely not the case. So I have strong opinions on this, and we'll go deeper into that in week 7 and 8. Classical machine learning is also kind of my spike, I guess, at Databricks. So I can talk a lot about it. Also, just a quick note on this. It's really interesting kind of where AI and LLMs are in terms of data science because you would never train a LLM. You wouldn't ask ChatGPT to like train you a linear model that like doesn't make sense inside of it. But these kind of LLMs can start generating the code to help supplement your data science. So this was again at Databricks. We actually authored a data science agent to help write data science code. But at the end of the day, you as the human still have to execute it, make sure it's doing what you want it to do, make sure the model is still good, and then use that to kind of give your recommendations. And again, actionable insights is something you're going to hear me say a lot. So you still, at the end of the day, have to be making the decisions off of it. But we can use LLMs to help be a shortcut to generating the code for it. Again, in my class, I don't really care if you use LLMs to help you through things, but just note that it's not, you're doing yourself a disservice if you don't at least read the code and try to understand what the code is doing, right? That's part of this at the end of the day. It's just like learning a new language, just like learning Spanish or whatever, right? Like you need to be able to read and understand and not just necessarily kind of see it generated on the page in front of you. Last thing to highlight on the syllabus is the capstone project. The last 2 weeks we'll have a guide. There's new content in week 9 specifically, but week 9 and 10 will also the hands-on labs will all be connected and will build towards a final kind of I guess capstone project where we are pretend working for SpaceX and we're going to be trying to predict and kind of provide cost estimates around the viability of reusable rockets, which is pretty cool. Not the moon base yet. You may have seen that on Twitter yesterday about how SpaceX is now going to be creating a reusable moon base. I think it's going to cost billions and billions of dollars, but we'll see. Anyway, it should be fun. And like I said, those hands-on notebooks, it'll be just like the first 8 weeks, except that we'll be using the same data set. We'll be doing a data engineering lab and then a modeling lab and then a data visualization lab. And you'll see the data evolve across all those notebooks. And then finally, your deliverable for the capstone is just going to be a slide deck and a write-up. So take everything you did over those 2 weeks, shove it into a slide deck to present about what are your actual insights and how did you do it. And this will be a technical presentation and a technical write-up. So imagine you're presenting to a data science manager or a CTO at your organization. So we can be technical with the communication, but we'll walk through start to finish, E to E if you're hip, end-to-end data science workflow, work pipeline. Yeah, there's also a million acronyms in data science, so I'll try and like call myself out if you hear me kind of just dropping random, I don't even know, cliche buzzword talk in data science, but it should be kind of fun here. Let's see. Last thing I wanted to review, the orientation models are also pretty thick in content. Um, the only thing, I think optional module A is pretty good. You could probably run through that pretty quick on your own time. And then optional module B was pretty excessive on things. So I think we'll talk a little bit on this. So one thing I wanted to call out was that if you go to some of these media sets, they can be pretty intense. I definitely recommend like still clicking through and reading up on them. But again, this is kind of an example of a module, right? So you go in here and you can see that we have a video to watch, we have some text and some more videos to watch that you can watch on your own time. I think you can watch them on double speed if you really want to. And yeah, again, these are just good like overviews. A lot of the things in optional module B, you don't have to feel like you understand at all. Like, what the heck is an API? Yeah, great question. We'll cover this in week 2, right? And then finally, unit 5, the R, anything with R and R Studio, you don't need to know in this class. It's good to know that R exists, but we're not going to be using R. And then in unit 6 on the optional module B, this is the IBM Cloud. And again, the IBM Cloud is going to be optional for this course, and you should all have free access to it. There is a like free registration link somewhere around here that I can get you set up for. But any hands-on lab that uses Watson is optional in the core in the cohort here. So yeah, last thing I want to do here before we start diving into some week 1 stuff and taking questions on things is we'll just walk through kind of what a normal week is going to look like. I'll say module 2 is kind of a crazy week, but we'll start with module 2. So for module 2, for example, you will start kind of with the main overview of kind of the unit. So in our case here, we're going to be learning Python basics, data structures, programming, and like how to write code in Python. And then this last section for unit 2 on data collection, we're going to do more of that in week 3. This is just kind of a fairly quick overview of it. But let's say kind of we want to get started on week 2. We're going to start with the very first media set. Again, those time estimates, those plus or minus, maybe I should highlight this first. These time estimates are wild. You don't need, I don't think they're remotely close. I think they're overestimates, way overestimates of the amount of time to take on these modules. In my experience, if you're putting in about 10 hours a week on this, 10 to 15 hours a week, you're in more than good shape, right? So if you're doing way more than 10 to 15, like I had some students in my last class do like 5 to 8 hours and they were fine. I had some do up to like 20. But if you feel like you're putting a lot of time into this, like way more than 10 to 15, let me or Karen know and we'll try and help you kind of optimize or streamline kind of your workflow. So that's kind of the expectation. This is a asynchronous on your own time. If you have a job, this shouldn't like impact your job at all or anything. So like I said, 10 hours a week is my rough estimate. Karen, do you have an estimate on that? I might close the average of last with like 10 hours. You think that's probably fine?
Yeah, that seems pretty reasonable.
Yeah.
You
So
might
some of
want to
these
spend
will,
more, explore things and you know,
yeah. And
and play
it'll
around with stuff.
fluctuate week to week. So week 2 is a really heavy week. So maybe you're spending closer to 15 hours on week 2, but week 3 is a much lighter week because you've already learned the basics of Python and it's just going to be kind of applying that to engineering. So maybe week 3 is only a 10-hour week. So I'm looking for an average around 10 to 15 hours across all of them. So yeah, some of these though, like, oh my God, 220 minutes. Like, no, if you're spending 4 hours on this one module, like what are you doing? But anyway, I want to give an example of kind of what these modules look like. So let's say we're going to start with 2.1. It's going to start with just again some text, and then we'll work through some videos. Again, I love Python, so hopefully this isn't just me saying how much I love Python, but also telling you why blah blah blah. And then here we go. So after we got here, so this is within 2.1, we have our first lab. So you're going to see these highlighted. I think the labs are some of the most important pieces to the cohort content. So we're going to run through a couple labs in week 1 here. But for example, this is going to be a real one. So if I open this up, it should open up a cloud computer which is pretty cool. So this is not running on your local computer. This notebook is going to be running on the IBM cloud, which is pretty cool. So all this means is that behind the scenes, this is called a Jupyter notebook. This Jupyter notebook is running on a virtual machine that's deployed on a cloud server. So we'll talk a little bit more about what the cloud is and stuff next week. Um, but when we execute code here, this is not going to be running on our laptop. This is going to be running on the cloud computer. So you don't really have to install Python, which is great because installing Python is a pain sometimes. You don't, especially across Macs and Windows. We don't have to install custom software. We should hopefully just be all running the same consistent software on the same kind of cloud containers. So that's kind of the like idea here. So one other quick thing to note on the notebooks is that it's gonna say again, this is gonna be like hands-on. So it's gonna be something like this, right? Your first program, try using the print function to print hello world. It's recommended you start this on your own, but usually most of these notebooks will have solutions, so you can just copy and paste this up if you want. So that's kind of the idea here. So this is again like a hand, we're holding your hand working through this notebook. Not every notebook will have these solutions. Like I said, the further you get along into the week, the notebooks near the end of the week don't have solutions, and you have to write those yourself. And that'll be the ones that I will prioritize in reviewing during our live sessions. Cool. So again, week two has a lot of these labs, but they should all go by pretty quick. And like I said, I think if I click next, we may be almost done with module two. So we have some more notebooks, another lab, and then a little quiz. And then these quizzes are not graded on the media sets, but yeah, that's it. Then we get to the conclusion. So that was media set 2.1. And if I go back to my unit here, it said that should take me 50 minutes. You'll probably get through it in like 20 to 30. And then this is especially more excessive for like the 200 kind of minute ones. So that'll be the typical flow that you'll do. Find some time, watch those videos, do the hands-on notebook, and then give yourself a pat on the back. What actually matters on the module sets? When you get near the bottom, like I said, there'll be some of the hands-on labs that require more time because they don't have solutions, or they may just be longer. So definitely take your time, especially as you get closer to the end of a media set on the hands-on labs. And then two, what actually matters to each of you is this assessment quiz. At the end of each week, you will have a little what is it? It's just a little multiple choice quiz that looks like this. So this is 20 questions. This is graded. This does count towards your overall like course grade. The way that they do it is like each of the quizzes is maybe like 3% or something or 1%. And then the capstone is 70%. So it should be these don't count a lot towards your grade, but they are still officially graded to make sure that you actually work through each week. What Karen and I can control, I can go in and change grades on anything. So if you have, I think maybe week three, there's a couple of these quizzes that have like weird questions. So something that Karen and I look out for is like if everybody misses the same question and I review it and I think it looks silly or that the answer didn't make sense, I'll go back in and manually update everyone's grades as needed, or just call it out in the forums, which I'll review here in a minute. Brian, do you have a question?
Yeah, so these quizzes are not necessarily due like at the end of each week, right?
They are at the end of each week,
Oh, really? Okay, so we
and
do have
they
something due coming up soon then for module one.
not module one. I don't think
Okay.
there's a module one quiz, but starting in week two, there'll be a quiz. So we got two, three.
I think there
Yeah, so
is a
starting
quiz.
next week.
I think there is a quiz on module one,
Let me
assessment
see.
that we need to
Yeah,
do.
Oh yeah, there it
assessment,
is.
yeah.
110.
Yeah, yeah.
Yeah,
But I
110.
think it's not like I say, it's not due until like April 8th.
Yeah,
Hmm.
that's when the course closes.
Oh,
So, yeah,
oh,
technically my recommendation would be to do the quiz each week. Otherwise, it'll be April 8th, and you're going back and doing a quiz from week one just to get all the grades in. So that's a good thing to call out, though, Brian. The way that the course gradebook works is I think Wednesday, this is officially the last day of week 10. I think it ends on Tuesday, the 7th. So then Karen and I have a few days to finalize the grade books. We have to manually grade all the capstone projects. And I try and review the quizzes every single week just to make sure that the grades and things look fine. But if you submit things late, then I have to do that too. So we have about what, Wednesday, Thursday, Friday, Saturday, Sunday, maybe to finalize the grade books. So early, whatever that Monday, Tuesday is after April, that's when everything needs to be finalized. So again, you could wait until the very end to do all the quizzes, but I don't recommend doing that.
Yeah, you just answered
But
my
good call out.
question. Yeah, because I wanted to ask whether we should do the assessment of the quiz before we, is it compulsory to do the quiz before we actually continue with the next module, Alexander? So it's not, you can actually do it afterwards or whenever you want, but it's not
It should,
recommendable. Yeah.
yes. So yeah, so first, correct. There is no prerequisite to unlocking the next module. I think module one is locked until you verify your identity, but after that, all the modules unlock on a time. So starting on February 11th, that's when you can see all the crazy stuff of how big week two is. But the week one quiz is not going to be a requirement to access the week two materials. And like I said, the quizzes are really just there as a very, very small incentive to actually put the time in to work your way through the modules and do the hands-on labs. Otherwise, technically, you could just not do anything for 10 weeks, show up and throw a slide deck together on the SpaceX use case and graduate. So we have the quizzes there in as just again, they count very little towards your grade, but just having them there as a due date and a deliverable usually incentivize the students to put the time in to actually watch some of the videos and take the quiz at the end. And I also recommend taking the quiz after the live session because I usually answer a lot of the quiz questions. Or I guess I also had students that do the quiz before the live session so they can call out specific questions that they didn't like. And so then I can go in and answer them for them or talk through
Mhm.
the class. So whatever you want there. And that's also a good segue into how I want to talk through the discussion forums. So going to the discussion forums, they will look pretty similar to week one in all future weeks. So you're going to have a couple of I call them targeted discussion prompts that again are optional, technically. I wish the discussion prompts were graded, but I'm not allowed to grade the discussion prompts. Anyway, these are optional, but Karen and I are very involved in the forums. That's where we log in every day and kind of record our hours is by kind of supplementing and adding to the forums. But you'll also see a lounge. I mean, I call it a lounge. So this lounge area, I also recommend kind of following. You can follow the forums, and that means when I post in them, you get an email. So the lounge, this is where I forget we just talk about stuff related to the week. So Karen's got some good kind of links here. And then I added in kind of some quick things around the purpose of the week, as well as the live session, my GitHub, and a couple documents that we'll review here on the live session shortly. I'll also post things like the video recording, and I also will do like a 15-minute weekly recap at the end of each week. So I'll post that here as well. So yeah, I create 2 videos every week, which is fun. But yeah, I'll make sure things are posted in the lounge. And you should also be following the announcements, which should also hopefully you see things here as well. So if you ever not see an announcement, let me know. And trying to thumbs up things. I don't know if anyone sees any of my posts unless you like thumb it or like respond to it. So just try, no harm in giving a like or a thumbs up to things. It just makes me feel validated and seen.
Yeah, so
Otherwise, yeah.
so for some reason I don't see this sidebar on the left. Like do you have any idea?
Yeah, I do see like these
Yeah,
three
yeah,
little.
I have this left panel, but then like I don't see this like a drop down, like a sidebar drop down like, for some reason.
If you scroll
But
all the way down, do you at least see the live sessions there?
no, I don't. I click it. I get into this Zoom call like through the link that you provide like in the
Oh,
discussion
weird.
section. Yeah, that's weird. Yeah.
What
Karen, is
browser?
that expected?
What browser do you have?
Chrome.
Oh, because I have Chrome too, so it shows up. I'm just wondering. Sometimes different browsers don't work as well on
Mhm.
platforms.
Did everyone else just click the link, or can you actually see this live session down here at the
No,
bottom?
I don't see it at all. So
Yeah, for the rest of the class, though, like
I
Grace.
don't see it either.
Oh, interesting. I wonder how.
I
I
don't
guess you
see
have
it
to wait for me to
either.
post.
I don't see the
Cool.
Yeah,
there.
me too.
Gotcha. Okay. Well, for the live session recordings, I'll make sure that those links are explicitly sent to you. And yeah, I'll follow up because I don't know. In the last class too, Karen, I'm not sure if anyone ever saw my announcements, but I'll duplicate announcements across the lounge. Long story short, pay attention to the lounges in the discussion posts, in the discussion forums each week, because that's where I'll be posting kind of weekly announcements, as well as things related to the recordings and additional content that I create. Don't
The
just
other,
focus
oh, sorry.
I was gonna say, yeah, don't just focus on the like targeted forums. Also look and follow what's going on in the lounge. This is also where you can ask questions. I usually have a separate forum devoted to live session questions, but that's also where you can just ask general questions about things like where do I see the recording, or can you just give me some recap about this quiz? Or if you have questions about the quiz, that's the general place I would
And that's
recommend
also a
posting those questions.
good place for questions if someone, for example, can't do the live session and watches the recording and has a question, that's probably a good place to post a question as well.
mhm.
Cool. And then I'll follow up with my supervisor on kind of the expectations around being able to see or get emails around the announcements.
Well,
Cool. And then yeah, it's the
one thing as
same
far
Zoom
as the
link.
session, though, the link is always the same. So even if you just bookmark it on your browser, you can always find it then.
Yep. Awesome. All right, so that's been the last 30 minutes. Let's actually dive into some of the week one content now. So hopefully we all kind of have week one, it's also a good soft introduction to the way that the module flows will work. As you've already seen, we have the targeted discussion forums that we recommend contributing to, as well as the different videos and quizzes that you have in the different media sets. So again, here's our little video about this is the Rollins methodology here, and then go into the discussion forums and things. So there are a few hands-on activities for week one, but we'll get to that in a second. So let's just go ahead and get started here. So the week one, the big idea, 10,000 foot view is just how to think like a data scientist, right? So to do that, of course, you can think about being analytical, making those actual insights, trying to compete with analytics, right? All of these different cliches about the purpose of data science. But it's also good to think about data science in terms of its methodology and what do I need to do with my data? And then how am I going to communicate my data? A lot of people think that data science is just kind of the middle bit of the methodology, making bar charts, making visualizations, making a write-up and a report, training a machine learning model and finding the best model and calling it a day. But the most important parts of data science are actually at the ends. How do I figure out what data I need? How do I clean it and prepare it for analytics? And then finally, at the other end, how do I communicate my insights from this beautiful dashboard, from my machine learning model? How do I deploy this into production to make actionable insights every single day, right? Or make better decisions every single day? At the end of the day, that's what data science is. It's a framework for fostering better decision making in the face of uncertainty. And I like to say that as well, because like none of us can really like understand where the future is going to go. There's always uncertainty in any prediction a machine learning model makes. There's uncertainty. Any recommendation you provide in terms of next steps comes with uncertainty. But with data science, we should be able to quantify or at least qualify that uncertainty in the scope of our recommendation using historical data, visualizations, and pattern recognitions to help us focus that future recommendation that we're giving to our stakeholders, right? So again, I came from a sports background, so I have a lots of like random like analogies and stories in sports. So again, I don't know how worldly a lot of this will be, but one thing that happened in Major League Baseball. So Major League Baseball is kind of a funky sport. Let me see if I can find like positions here. Let me see if I can find. Yeah, that's basically it's nothing like cricket where everything's like in a circle. In Major League Baseball, everything you have to like hit forward. So there's like one spot here called home plate, and then everything gets pushed forward. So traditionally, though, when you play baseball, your defenders always stand in the same spot. Our first baseman always stands at this 3 number. Our center fielder always stands at this 8 number. And this was just convention for the longest time. People have been playing the sport for 150 years. People stood where they've always stood, whatever, right? So when I actually joined my team that I started with, we started looking at this in a little brand new light, and we said, "There's no rule that says you have to stand here. Why don't we move our defenders around where it's more likely that someone is going to hit the ball?" And they do this in cricket too, right? It's pretty funny looking at like when you got the power play on where people can stand, or if you know a guy usually tries to hit for 6, like you stand a little bit deeper. So like same thing, like why don't we move our players around? And in baseball, what ended up happening was that, let me see if I can get my pen. If you're left-handed, you're more likely to pull the ball or hit the ball this way. And if you're right-handed, you're more likely to hit the ball this way. And so what ended up happening is if I know that a left-handed person is going to come up to hit the ball, why not just put all of my defenders on this side, right? Why do I have to have 2 and 2 when I know that 9 times out of 10, this guy's going to hit the ball to the right? And so this ended up being called like a defensive shift. And so it was really cool because I was able to help like the Rangers build a model to predict using unsupervised learning, which we'll get to in week 8, where a person should stand based on a historical pattern of where that batter usually hits the ball, right? And so that was really interesting. But as I said earlier, there's uncertainty around it. I can definitely make the recommendation that, hey, let's have all of our defenders stand on the right side of the baseball field. But like I said, 9 times out of 10, it'll happen that the guy will hit the ball there. There's always that 1 time out of 10 when this guy, for some reason, ends up hitting a ball out to this number 7 guy, and everyone's like, "Oh my God, come on, Booth! If we had a defender here, we would have been able to make the play and get him out." And I'm like, "Sure, I know, but quantifying the uncertainty, I would rather take that 1 out of 10 probability than miss like 5 hits on this side because I only have 2 defenders." So again, it's like talking about how to quantify this based on uncertainty and finally making that recommendation. And then the last thing that's really interesting on this is that baseball players themselves, they're athletes, right? They're athletes. The coaches are athletes. They're normal. They've played the game their whole way, their whole life. So I was communicating a data science recommendation based on the data, based on a machine learning model, but I had to get it actionable on the field. And so that ended up being a very long process of trying to justify why, showing them video, showing them visualizations, actually communicating the responses from my reports to try and get that to happen. And it eventually did happen, which was great. But I like talking about this example because no matter what industry you're in, you always have non-technical stakeholders, which in my case were the athletes and the coaches, that may not understand what a k-means clustering model is, or definitely don't understand what Python is, that you need to convince to actually make the decision or make the change. And being able to communicate and justify in their language what your analytics and what your data science is trying to communicate is so important. And again, that's kind of that last tail piece. So yeah, I think this is kind of a little fun example. I don't know how I started talking about this. Yeah, I have a lot of examples where I'll start relaying stuff back into sports. But in my work at Databricks, I also work with a lot of large Fortune 500 companies, as well as sports and sports tech organizations, to try and get data science actionable. So yeah, I'm very passionate about that communication piece. But anyway, we're going to walk through kind of what that methodology looks like to go from 0 to actually making a decision in terms of kind of these different data science frameworks. So the first one I want to bring up, and again, I'm not sure where it is in the media set here, but the first one I want to bring up is the CRISP DM overview. The CRISP-DM methodology has been around for a long time. This was kind of the very first one back in the early kind of like maybe late 90s. So a little quick history of computing, right? Starting in kind of the late 90s is really when data science started taking off. Before that, we've had relational databases since the 70s, Oracle, Microsoft SQL Server, which we'll get into in the history of databases in week 4. They've all been around for about 50 years now. But it wasn't until kind of the 90s that we started getting open source databases such as Postgres and MySQL, as well as, of course, the advent of the dot-com boom and the widespread kind of usage of internet and computers to be able to do these analyses. In fact, a lot of the machine learning models we're going to talk about, things like random forests and neural networks, they couldn't exist without the computers and the supercomputing power that we have today. But anyway, this methodology goes back at least 20 years, probably 30 or 40, depending on who you talk to. And it's supposed to be a cross-industry way of just thinking about data science. So this has a lot of limitations, especially in the scope of modern big data analytics, but we'll kind of just walk through it. So we always start with the business understanding. This is always the biggest part, right? What is the business question that's being asked of me, and how do I frame it into a data science question, right? So again, coming from sports, American sports are super weird. We have what's called like a draft every summer where you can go and select a college player, a college athlete from university, and add them to your team. So a common question like my leader on my sports team would ask was, who should we draft from the college kids this summer, right? And that's not really a data question, right? It's more of there's a lot of factors that go into which player do you think you should add to your team. So being able to take a business question and translate it into data is a really difficult but really important piece of data science. I also like to think about data science in terms of the scientific method, because it is a science, right? And so with a scientific method, you have to create hypotheses. And if you have a question that can't be answered with a hypothesis, science buddy, verifying I'm human, that's wild. How many AIs are trying to visit sciencebuddies.org? That's crazy. Anyway, with the scientific method, right, we have to construct a hypothesis that's testable with data, right? We have to be able to test with an experiment. If we have a scientific question that's like, do aliens exist on Mars? We can't really test that, right? It's an experiment without data, without something that we can gather and quantify. So same thing for regular data science in the business world, right? Which stock should I invest in? Great, that's a great question, but I need to be able to define that question in terms of data, right? So maybe we look at something like which stock was the most profitable over the last 4 quarters? Which stock has the least amount of volatility? Which stock does my model predict to perform best in the next 4 quarters? Those are questions that we can answer with data, with models that can try and give us certainty, right, in the face of uncertainty in terms of this business question. So same idea with the draft. Which guy should I draft in July? We could change that to be more data driven by saying which college players performed best against players similar to those that play Major League Baseball. Which college players are predicted based on my forecasting model, my regression machine learning model, to perform best in 5 years from now, right? How many home runs do I predict this guy to have against a 95-mile-an-hour fastball? So again, these are data-related questions that we can answer with data and models. So if you don't think that the business question can be answered with data, that's when we have to work with your executive stakeholders to reframe the question to make it more a testable hypothesis. Finally, once we figure out the question that we want to answer, how many home runs do we predict this guy to have next year? Then we have to talk about the data. What data do I have? What data can I gather? What data can I collect? And what does this data even mean? Right? Because again, at the end of the day, you could have the best question in the world, but if there's no data on it, or the data is untrustworthy, then you're still not going to be able to answer the question. Right? So that's what this data understanding comes into play. What data do I have at my disposal? How can it answer my question? And what do I need to do in terms of manipulation to be able to get that data to where I need it to go? So let's say your business question is, I want to know which stock you think is going to perform the best over the next 4 quarters. Great. That means I need historical performance of the stock, maybe daily records. I'm going to need to make a model to predict using time series what the next kind of fluctuations will look like over time. I need to figure out if there's seasonality involved in any of this. And I have different vendors, Yahoo Finance and I don't know. I have all these other vendors giving me this data. I need to choose where I'm going to get this data from. That all comes into this data understanding level. Then comes the traditional data science that I know we all kind of know and love and think is why we signed up for this course. Data preparation, how do we clean the data? How do we make it our rows and columns? How do we get rid of null values? How do we clean everything up? How do we build a classical machine learning model on it or make this data available to AI agents to start making decisions and synthesizing with other data sets around the world? And now we have a result, right? We have a white paper that we put together. We have a model that we think is pretty good. We need to evaluate our results in terms of the business question. And finally, if we think that this is a valid solution or a valid recommendation, we then deploy into production. Or deployment can just mean going back to your executive stakeholder and presenting your slide deck, presenting your recommendations, and trying to make that recommendation actionable on the field or actionable in wherever kind of their use case will be. So big ideas of the crisp DM. What is the business question? What is my data that I have available to answer that business question? How do I clean the data? How do I make my data product, whether it's a dashboard or a machine learning model? Is my product any good? Does it actually answer the question? And then how do we communicate the results back to the stakeholders? So it's a pretty good framework for thinking about a data problem. The biggest problem that we have with this framework is that it doesn't necessarily reflect the iterative nature of data problems today. So, for example, with this like defensive positioning example, great, this will work for a given year, but let's say that a batter changes their approach. Next year, this left-handed hitter, he's now purposely trying to hit it more up the middle or more to the left. Or there's a rule change, which they did. Major League Baseball actually banned this. They did put in a rule explicitly saying you had to have two guys on either side of the middle of the field starting in like 2023. It was crazy. But maybe there's a change, right, in the reality of the world that forces you to reevaluate your recommendation and your model. With the crisp DM methodology, if there's a major change like that, that's not necessarily reflected. We call this in the industry things like data drift, which is where your data is different in a given year or a given month, or even other causes of kind of drift in terms of, model drift. Model drift is where your model is making predictions that aren't relevant to the, ooh, look, IBM's got a link on this. They don't have, your model is making predictions that is not necessarily reflective of the current state of the world. We call that kind of model decay. So again, if I'm trying to predict which stock is going to perform the best, and I'm using a model that's trained on data from 2021 to 2023, that model is probably not going to be that relevant in 2026, right? There's been model decay. The model is not representative of the current state of the world, right? So that would be something like an MLB where they banned this rule. They banned the defensive shift. Now my model is very decayed because it's really not reflective of the world around me. So those are the two types of drift or changes that you see kind of in big data. Data is changing. My consumer behavior is different than I expected. I have data drift, or I have model drift. My model is no longer reflective of patterns in the real world. You're going to hear me emphasize patterns a lot. All data science is, at the end of the day, is pattern recognition and then communicating decisions on those patterns. So when we make dashboards, when we make beautiful. I don't know how many of y'all like follow like data is beautiful or like create looking at different dashboards and things. We'll get into this in week 4 when we start talking about or week 5 when we start talking about visualizations. But to me, a data product is a dashboard or a machine learning model. It doesn't have to be kind of the same thing. So maybe I have like a dashboard that looks something like this. Oh, this is from biotech. Pretty cool. Uh, Oh my God, that's also tiny. Again, same deal, right? Is the patterns that I'm identifying here, are those still relevant to today? And with humans, humans are really good at finding patterns, better than LLMs, by the way. So being able to show something like this to a human allows us to really kind of make actionable decisions quick. This is a terrible dashboard. I'll have to find a better one. But yeah, long story short, the data products that we create as data scientists reflect patterns seen in underlying data. And if those patterns have changed because of the data itself or because of the world around us, then we need to update and reflect new modernizations of our data products. And that's really where the Rollins methodology comes in, who's also from IBM, which is kind of funny. But I like this one a little bit more only because it explicitly adds feedback here. And it also goes deeper into the data engineering piece. So there's two things I want to highlight on the Rollins method that makes it different and more representative of big data workloads. So first, we always start with the business question. What is the question that we need to answer with data? Then they explicitly go and call out this analytical approach step. This step is the most important. This is the translation of the business question to a data question. What is the data question that's underpinning this business question? So again, in the CRISP methodology, this was all kind of one big step, but Rollins breaks it out. Given that we now have a data question, let's talk about what that data needs to be. What does it need to look like? What shape does it need to be, and how clean does it need to be? Where am I going to get this data from? And how trustworthy or good is this data? I use trustworthy a lot in data because you'll see that a lot of data sets, they may have a lot of missing values, they may have a lot of duplicates, they may have a lot of I don't know, cross contamination in them that may not make them as trustworthy. In fact, in one of the discussion posts, I think Karen called out that something was a synthetic data set. That's a fake data set made for just educational purposes. So don't want to accidentally use that in a real world, I guess, scenario, right? So yeah, make sure you understand and trust the data. And then we get into the real data science, which again, the real data science is only 2 steps. How do we clean and prepare the data? And then how do we create our data product? And again, this modeling aspect, this could be modeling your data as a dashboard or it could be modeling your data as a machine learning model. Or even now in modern data science use cases, I see people whose data product is an agent, an AI LLM chat interface, right? So we may have heard about RAG or where you can chat with your data. That's also a data science product. I'm going to create an application where my user can log in and chat with my visualizations, chat with my model outputs, or even chat with the underlying data itself. Again, I'm not gonna like try to pitch so much Databricks stuff, but what Databricks is doing is representative of the entire industry. So for example here, Databricks has a product called Genie, and I'll show other examples so you don't think I'm just pitching Databricks. But Databricks Genie is a chat overview. You can ask questions of your data, and it goes and queries the data sets behind the scenes, and it even synthesizes and returns responses back to you. So, and this is also a very popular type of data product. And again, the underlying data set could be your machine learning model predictions. It could be the clean data set that you prepared. And you can even do this on dashboards. So for Databricks, it's actually like in dashboard. Let me actually pull the dashboard up. Like you can actually have a visualization, right? Like this. So this is a dashboard, and I can chat with it down here in the bottom right. And now I can help my end users synthesize and receive information from this dashboard, as well as the underlying data set quickly. And again, I'll share some of these links after class, but just so you know that this is not just a Databricks thing. In Tableau, they have something called Ask Data, which is like very, very similar, where you just ask, oh, this is a video. Basically the same thing though. You ask questions about your data and it starts returning kind of insights back to you. So yeah, this is a very new data model, but it's at a 10,000 foot view, it's the same idea, right? What is the final, where's my dashboard? What is the final product you're creating? Is it a dashboard? Is it just a machine learning model? Is it a chat interface with an AI agent? Maybe it's all the above, right? And if it's a machine learning model, does that need to be creating predictions every day? Does it need to be creating predictions every hour? Does it need to be creating predictions every second? And again, you see this too. Like there's some, let's say that this is a bad example, but let's say that I have a model that's going to predict if someone is having negative language in their tweets, right? There's millions and millions of tweets a day, hundreds of thousands of tweets a second. I need my model to be providing predictions on every single tweet that comes through, if it's a negative or hate speech oriented tweet, right? So now my model, my machine learning model needs to be creating inferences, that's just predictions, at a rate of thousands a second. And again, this is where things get pretty cool. So now you have to talk about what does the technology look like in a streaming sense, which is like really interesting. Again, streaming sense is just every second I need to do something to my data. Well, batch means every hour I need to do something. Again, we'll talk a lot about this going into weeks 4 and 5, but yeah, real-time processing versus other ones. And again, these are all things to consider when evaluating your model. Last thing, just to go on to the thinking like a data scientist, again, things to like think about is great. Again, does my final product relate back to my business understanding? And again, this is where I like Rollins because now we can see that my arrows go backwards, right? And my arrows go all the way back to the data set. Do I need to get new data? Do I need to clean my data in a different way? Do I need to create a different model? Do I need to prepare my data differently? Right? So we have this continuous feedback loop of the data product itself. And then finally, we have deployment. We're going to either present our capstone or we're going to deploy our machine learning model or we're going to deploy our agentic dashboard chat app thing. But then we're not done. Again, in Crisp, you're done after you deploy it. You call it a day, get yourself a nice cup of coffee, and go to bed. But in the real world, for real data science, we have this continuous feedback loop. This is where we're automatically checking our data product against things like data drift, model drift, or even stakeholder complaints. You'll see a lot of like agentic apps. They have when they generate a response, think about your last experience with ChatGPT. You always have like a thumbs up or a thumbs down, and sometimes ChatGPT even says, "Did you like this response?" So that again, that's the user feedback. So we have data detect. We want to detect data drift, model drift, and then maybe even user drift or user experience. And it's actually pretty cool because in the real world, you have a lot of ways that you can start iterating automatically based off this feedback. So, for example, you can all have automatic model retraining off of data drift. So basically what this means is that if my data is different than it was when I trained the model, I can automatically detect it and then kick off a job to retrain the model on the latest data if possible. So, and baseball is actually really interesting. There's a lot of seasonality effects in baseball and also a lot of weirdness year to year. So basically, long story short, in 2024, I think, or 2021, when do we think the juice ball was? 20 maybe 2021, 2019. This is the wrong one. Anyway, long story short, there were rumors going around that the baseball was different in 2020, maybe this one, 2020 or 2019. Like the ball was bouncier basically. So because the ball was bouncier, when you hit it, it was more likely to go for a home run. So all of my beautiful models that had predicted whether or not a hit would score and go out of the ballpark, that model was irrelevant in 2019 because the ball was different. The whole like ecosystem was different. It was much more likely with this new ball to be able to hit that home run. So again, that's where this drift comes into play. And luckily we were able to detect that pretty quickly because my model would predict something like 5% of all hits would be a home run, but in 2019, 8% of all hits were going for home runs. So you're able to track that pretty quickly and go, oh my God, my model is completely off. I need to retrain this on the new data sets to make sure I'm predicting that 8% all home run number or something. So again, that's where the feedback part to the methodology really comes into play, right? You always want to be monitoring your data product to make sure that it's continuously delivering trustworthy and actionable insights from the data that's underpinning it. Love it. So yeah, again, these are just ways of thinking like a data scientist. In my day-to-day job, I don't translate every single problem I get into these methodologies. Instead, I like to think of everything from a 10,000-foot view. What is the question that's being asked to me? How can I use data to answer this question? What do I need to do to this data to be able to get it ready for the data product? And then finally, what data product am I building and how am I going to build it off of this data set? And then finally, does my data product answer the question? And my data product can be anything from a dashboard to a machine learning model to an agentic LLM application and everything in between. Not bad, huh? I have some follow-ups to this to take us to the next 15 minutes, and then we'll be done here. But any questions from just like thinking like a data scientist or my like quick review of these methodologies?
Yeah, I'm just thinking, if you look at this whole concept, it's like when you're a web developer and you build a website and it continuously changing, or the requirements changes all the time, or it's getting updated, then you always have to go and tweak your website and the output of it. So it sort of works the same way. It never stops. You're always continuing to change it and update it with whatever, for getting the feedback from various users and the client that owns
Absolutely.
the requested website. Yeah.
So I actually spend a lot of my time actually collaborating with like real web developers and front end and back end kind of developers. So this is a website, but every kind of baseball team has like similar websites. And you can think of it too as like just an internal analytics tool. So we would have web developers make this website together, and you can already see how we're using visualizations to kind of relay patterns and things. So maybe you don't know anything about this guy, but looking at all of these red bars that are close to great, you don't have to know anything about baseball or American sports to go, wow, this guy, he's pretty good at baseball, which, yeah, he is. He's like the best player like in history of baseball. But kind of where I would work back, especially when I was an individual contributor and actually kind of doing machine learning and making these models and things, you would have like here, because it's going to be kind of hard to see. And I'll zoom, I'll post this in Zoom real quick if you wanted to see it. Let me drop this in chat. Boom, boom. And I'll post more of these links too, like I said, after class. But what I wanted to quickly show here is these columns right here, these ones that all begin with an X, these are machine learning outputs, right? These is expected batting average, expected slugging, expected WOBA. You don't have to know what those stats are. Just note that in real baseball, you have the observed, which is this guy right here, like observed batting average. How many hits on average? How often does this guy get a hit? So on average, this guy got a hit 25% of the time. And then you have expected, which is based off of a machine learning model. So I would build a model that said, given how hard this guy hits the ball, if he hits this ball 100 miles an hour, then 9 times out of 10, that's a hit, right? And so maybe he just got unlucky those few times that he did get out. So I have a model that's going every night and making predictions saying that on average, I would expect him to actually get a hit 28% of the time. So now we have my machine learning output with this output. But to tie it back to James's comment, I built the model and then I deployed it into production where every night it's making new predictions. But I had to work with a web developer to get those predictions onto the website where things are being kind of fed to me. And again, to go back to how often these models need to run, there's a baseball game every single day. So guess what? There's an updated batting average and an updated modeled batting average every single day as well. So that's again when we talk about deployment. I have to kind of make sure that this is making those predictions every single night. And that means I have to have some type of auditing, transparency, observability into how that job is running. So we actually have a whole new, hopefully this is out of scope for the boot camp, but there's actually this whole idea of data quality and data monitoring as part of your job as a data scientist, right? And yeah, sure, you can do it now with AI, have ChatGPT monitor your data for you, but this is still just a way of something that we have to think about as data scientists. How do we continuously monitor the health of our data systems? Right. And again, I love how systems now expands more than just back end and front end web development. Systems also interplays with the data science workloads that we have to create in both engineering as well as the output at the end. And yeah, last thing I just want to clarify here. This idea of data science does have specialized roles in it. If you go on Indeed or LinkedIn or Monster and you look for jobs, you'll see some people being data engineers. That's their whole job. All their job is to clean and prepare data. Then you also have machine learning engineers, and it's their whole job to deploy models into production or train models, right? And then you'll also have like DevOps folks whose their whole job is to deploy and have this basically continuous deployment and continuous evaluation. You also have data quality engineers, uh, yeah, QA engineers basically for data. And it's like all they do is double check to make sure this data is reliable. So as data scientists, I like to think that if you actually get a job as data scientist, it's a unicorn position because you're expected to be familiar with all of these concepts, even if you're not necessarily specialized in one of these concepts. And that's also this case for this class as well, right? We're going to give you exposure to creating these models, creating databases, cleaning the data, monitoring your data, being quality assurance, deploying your models, DevOps and stuff. So you'll have exposure to all of these different things. But if you're feeling overwhelmed just by the scope of responsibilities of this pipeline, yes, you should be because there's a lot of work that has to go into it. But this is now why we have teams of data scientists or teams of data systems engineers working to create and monitor all this, especially with this age of big data on cloud technology. Last thing, just on housekeeping items. If you Karen's role during the live sessions is to monitor chat as well as keep track of random links that I pull up. So feel free, definitely, if you have questions while I ramble, if you have anything to mention or want some additional clarification on things, utilize the Zoom chat, please. Put Karen to work, have her respond, and give you some updates in there. And we'll also kind of debrief from the chat too in my kind of recaps that I post. And also, I think you can raise hands in Zoom. So that just also makes me see if you have a question. I know to shut up and make sure that you have the space that you need to talk to me as well.
You mean I have to be useful as well as decorative?
Yeah, exactly. Last thing I want to go over here, just about 10 minutes or so, because I still plan on getting you out a little bit early, is I kind of wanted to walk through the different like hands-on examples for week one. For two reasons. The first is to get you experience with being comfortable in the Jupyter Notebook labs, because you will be hands-on a lot in week two, right after this live session. And then two, just to also reiterate what this methodology looks like on a real-world data set. So I'm going to cheat a little bit and scroll all the way down here to the bottom. If you've already followed along, you'll see that you have three hands-on activities, one in 1.3, one in 1.4, and one in 1.6. So I'm just taking these as a shortcut. But as you're working through your modules, you should be able to see these as well. So as mentioned at the beginning of the lecture, when we open up a hands-on activity or a hands-on lab, it'll look something like this. Again, this is Jupyter Labs running on IBM Cloud. And you have a welcome tour that you're more than welcome to click through as well. But essentially, these are going to be notebooks where we're going to be able to write Python and SQL. And even later on, I forgot, we even do apps. We're going to be building what's called data applications, which again is kind of where these agentic AI chat interfaces can live as well. But we're going to be building data intensive applications in the second half of the cohort. We're going to be doing all of that within this cloud ecosystem here. So when I open this up, we can talk about the first stage of the problem here. So our big problem is around food. We want to know, maybe the question is like, maybe what I want to make for dinner tonight. But maybe it's something more intensive of like what type of food should my new restaurant franchise serve, right? What's going to be the most popular like restaurant food in this area? Or kind of what ingredients am I gonna need to be able to source my new restaurant's like food. Maybe that's the better example because this is going to be all about like cuisine, like ethnic cuisines. So maybe it's like, what ingredients do I need to have most on hand to source my new ethnically cuisined restaurant or something? So we can translate that back to a data ask, right? Well, how do we do that? Let's say that I'm going to need to pull a whole bunch of ethnic recipes and I want to break down the ingredients within those recipes. And I want to identify patterns and the likelihood that certain ingredients will be present in certain cuisines. So that's going to be kind of the way we break down this business question to a data question. So in this first notebook, all we're doing here is great. We have the business question. What foods do I need to have on hand? We have the data question, which is let's actually pull all of these different ingredients and relate them back to a cuisine. And now we can go into, well, how do I even get this data? So there's a lot of open source data sets on food out in the world. If you've already done your 1.2 discussion post, hint, hint, get that done. You have to go out into the world, go out on the Kaggle, and find your own data sets in the world. But things like Yelp, All Recipes, they all have different APIs and databases where we can kind of pull, I guess, different recipes from them. So here we go. We actually have done this already for you. We've already gathered a CSV, which is just a flat file, kind of like Excel file, of recipes. I'm just gonna run this cell. To run the cell, I clicked into it and ran Shift Enter. I think if you're on a Mac, it's gonna be Command Enter, maybe still Shift Enter.
So
But we
you're a
should
little
have
bit,
downloaded.
hello Alexander, sorry. You're a little bit quick. Just
Yes. So we'll see that our recipe is downloaded here, and they are right here. And we can now read in this data set into a data frame, which you don't have to know any of this code. This is just an illustrative example of what we're going to be doing over the next few weeks here. And again, if we show, this is what our data set looks like. We have the cuisine of the country, as well as all these ingredients and whether or not these ingredients are present in our cuisine. And we have 57,691 rows, which is a lot. So now where we've gone through on our rotation, we've acquired the data. Great. We even have a little bit of data understanding as well. So now we're going to figure out how we're going to clean and prepare this data and then make a quick model. So I'm just going to go in order here on our 3 notebooks. And again, all of these notebooks are already backed up on my GitHub already. And I will upload these notebooks as well to the live session spot too. And again, for week 1, you don't need to know the code. Just get familiar with the UI and how to kind of run cells in here. So same idea for this use case. We're going to pull in the data sets that we already gathered. And now we can go into the second half, which is the data understanding and data preparation. So the first thing for data understanding, let's just validate some assumptions, right? Does this data set contain ingredients like rice or soy sauce? Again, this also gives us trust in the data set itself as well. I hope I haven't crashed my kernel. This always happens with these notebooks on whether or not they crash. What do you think, Karen? Do you think it's alive? Sometimes you got to be nice to it or restart it as well sometimes. But if this is breaks, I'll just review my notebooks, which is why I back them up. Yeah, I'm just going to pivot to my notebooks because I don't want to waste time trying to fight with this interface. This should work for you. Again, if you run into issues where this kernel looks like this means it's turning on, it's booting up. But this is a problem with cloud computers, is that you have to wait for things to turn on sometimes. So just give it time or hard to refresh the page and then come back to it. But as for the scope of example for this lecture, given that we've now downloaded our data sets, we can validate our assumptions with it, or maybe it's my internet. Oh my goodness.
You seem to be fine online, so
That's true. Maybe it's just GitHub being mad at me. There we are. All right, so now that we've downloaded the data set, we can validate that things like rice and wasabi and soy sauce exist. And again, all we did here was we checked the column names to see if they contained the words rice or wasabi or soy. So we validated our data, we increased our trust in the data sets. And then finally, we do some data cleaning. We rename the cuisine column. We consolidate a lot of the different cuisine types here. Again, we're turning like Pakistan and Pakistani and make sure we have one cohesive cuisine type for all of our different categories. And then the last thing we do is we switch our yeses and nos to zeros and ones. That's the last thing that's probably good to reinforce here. Models, visualizations, they all require your data to be numeric. So we'll talk about different ways of data cleaning categories and text-based data into numbers. But this is a very common one, right? Yes will be one, no will be zero. And now we can start doing things like getting averages and looking for patterns in those numbers. And again, just to validate, we check to see which cuisines have rice, soy sauce, wasabi, and seaweed, and they mostly are Japanese, Asian, and East Asian. So that's again validates some assumptions about the trust of this data set. And if we go all the way down, I think that's it. Here we go. This is where we take the average, group by each cuisine and take the average. So we can see here that 15% of African cuisines contain almonds. And if we do this for all of our cuisines, we end up with some really interesting patterns that we can identify. African cuisines most often contain onions, olive oil, garlic, and cumin. American cuisines most often contain butter, egg, wheat, and onion. But how do we get this profile? We have to extract our recipes from the internet. We have to collect the data, and then we have to clean the data. We have to get our yeses and nos, and we have to combine our cuisine types. The last thing we can do here is now that we've identified these patterns, we can train a model. And again, you don't have to go through the code, but we can train a model to predict, given the presence of some of these cuisines, right? Given the presence of some of these ingredients, what do we predict the cuisine to be? So this is kind of a fun example. In this case, we built a model to predict if a cuisine is Korean, Japanese, Chinese, Thai, or Indian, only based off of the ingredient. And again, this is a visualization of this, but we can see some really interesting things here. So for example, if a recipe contains cumin, which is going to be a false to this first one. So this is cumin less than 0.5, so that'll be 0. So does the recipe contain no cumin? That is false, so we do have cumin. Then do we have fish? Yes. Do we not have yogurt? That'll be true. This is most likely going to be a Thai recipe, so we ended up with this purple cell over here. If the recipe does have cumin, but no fish, so now we're at this green dot, and no soy sauce, it's likely to be Indian, which is down here. So again, you don't have to worry about what the model is seeing here, but using pattern recognition, we can identify patterns to help predict the cuisine type. That is your 10,000-foot view on this. Then what we have to do is evaluate the model. Did we even create a good model? This visualization, a confusion matrix, relates my predictions to the actual true outcomes, and it gives us a quick way to interpret model performance. Again, this is illustrative. We'll dive into this in week 8 and week 9. But in this case, I'm just looking at this graph, and it's not that great. If everything was perfect, you'd have a lot of 100s on this diagonal. So it looks like we're not that good at predicting Chinese food. We mix up, where's my little pen? We mix up Chinese food and Korean food a lot. We mix up Thai food with Korean and Indian. We're pretty good at Indian. Japanese food we mix up with Korean and Chinese, and we're pretty good at Korean food. So we're only pretty good at Indian and Korean. Chinese, Japanese, and Thai, it seems like we get a lot of noise, right? We have a lot of mix up between them. And maybe that's just because we have a lot of overlapping ingredients between those cuisines. Like, would you
Yeah.
expect to have a perfect model here? Probably not. And that's another thing to call out, right? You're never going to have a perfect model. This is a great quote to end my lecture on. I love it. You're never going to have a perfect model. So at the end of the day, we just want to make sure that a model is usable, that we can use it to help guide our recommendations and predictions in the face of uncertainty. Even this Indian one, if I predict a cuisine's Indian, I'm only going to be right 80% of the time. 20% of the time, I'm wrong. So you need to know your model performance to be able to trust the predictions from it. So there's a famous quote that all models are wrong, but some are useful. And this is Words to Live by Mr. George Box here. And we'll post this back in. And this is kind of the expectation of data science, right? Everything you do is going to be wrong at some point, right? Whether it's model drift, data drift, whether it's just that your model is not making perfect predictions, it'll occasionally make a wrong prediction. But we should be able to get useful utility out of them, right? And be able to make decisions off of them in the face of uncertainty. And that's kind of the last bit of this notebook. So in the end, what the notebooks in week 1 should illustrate to you is the full life cycle of the Rollins and Chris methodology. What's the business question? What's my data question off of that? What data do I need to go out in the world and gather? How do I clean the data? How do I then look for patterns in that data, train a model off of those patterns, and evaluate the utility of that model? And again, don't get caught up in the code. We're going to work on the code over the next 10 weeks, but do get caught up in making sure you're familiar with the Jupyter Notebook interface and kind of just spend some time teasing around with this and running some of the cells. And that'll get you at a good foundation for week 2. When it's expected, you'll be writing your own code in these cells and executing them as we start learning Python. Last thing I'll leave you with, just to recap some of the housekeeping notes. Week 2 is a pretty busy week, but take your time with it. Try and put as much time as you can. Note that week 3 is a lot easier in terms of time commitment because week 2, we're spending the whole week learning how to code. So if you have 0 coding experience, it could be a really long week for you. If you have some coding experience, it'll go a lot faster. Again, most of the hands-on module stuff are optional. You can put as much time in as you want or don't want. But try and get some foundation of coding in Python. One thing to emphasize is going to be the last couple modules of week 2, where we start going into that data collection and actually utilizing programming for data science. Please participate in the forums as often as you can, and then look out for me. I'm going to be posting a recording, a lecture recap, and then a weekly video recap. So there'll be at least 3 posts, 2 to 3 posts from me a week that I'll be posting in the announcements and the lounge, just to make sure that you have access to them all. Cool. I can stick around here for a little bit longer than half an hour past the hour, but thanks for being online and watching and having your video on and being engaged. And I'll stick around here for any questions. But thanks, everybody.
Thanks
Nicholas,
for your
you can
time.
sit.
I might have one question. Sorry, I missed the first 10 minutes. It's one Zoom meeting a week or 2 Zoom meeting a week?
Yep, it's one
It's
meeting, one live session like this a week.
Live session, sorry,
And
live session, okay.
yeah, so it'll be
And
one
after
live session lecture.
it's roughly 10 hours of works every day. Every week, sorry. 10 hours okay,
Yeah,
that's
so yeah, my recommendation is about 10 hours on average a week. Some students spend more than that, some students spend less than
It's
that,
okay.
and
Okay.
some weeks you'll spend more hours than others. For example, week 2 is a pretty heavy week. Week 8 is a pretty heavy week. But some weeks like week 3 and week 4 are not too heavy. The one thing
Okay.
why I emphasize that is because if you go to the start of the week, like for week 2, for example, it's going to give you time estimates here.
Yeah, okay,
And
that's
these
clear.
time estimates are not reflective of reality. because if you go down, one of them's like 200 and 200 minutes. Like you're not going to spend 3 hours on that unless you really want to, right? So don't trust these numbers. Trust your own time. And if you're spending much more than 15 hours, 50, I would say 20 hours was kind of what I had a couple students do last class. But if you're spending way more than 15 to 20 hours regularly over the course of the 2 months, feel free to talk to Karen and I, and we can help you prioritize what to access.
Okay, thanks, boss. Thanks a lot.
Of course. Cool. Otherwise, I can pause recording and we can take questions offline. Otherwise, have a great rest of your evening. Thanks for logging on. We'll be at the same time, same Zoom link for all 10 weeks, hopefully. So otherwise, I'll see you here next week on the 16th. For those in the States, we do have class on President's Day. So even though it's a national holiday in the Americas, we'll still have, in North America, USA, we'll still have our normal lecture class here. Free to say goodbye in the chat, and thanks for joining.
Okay, bye bye.